Hello everyone, welcome to the 26th part of microcontroller architecture and programming, that is interfacing LCD with 8051. LCD is nothing but the liquid crystal display, and in recent years the LCD is finding widespread use replacing LEDs, that is 7-segment LEDs or the other multi-stage or multi-segment LEDs. This is due to the following reasons. First, the ability to display numbers, characters and graphics. This is in a contrast to the LEDs, which are limited to numbers and a few characters only. Second, in incorporation of a refreshing controller into the LCD, thereby relieving the CPU of the task of refreshing the LCD. In a contrast, the LED must be refreshed by the CPU or in some other way to keep displaying the data. Third, ease of programming for characters and graphics. So this is the display of a LCD, and it is a 16 by 2. That means 2 lines and 16 characters. And here, this is the matrix. This is 5 by 7 matrix for each character. So we are using 16 by 2 LCD, and 16 by 2 LCD means maximum 16 characters per line can be displayed, and there are 2 lines. So single character is displayed in a 5 by 7 pixel matrix. So this is the LCD. These are the 2 rows, and each row will display the 16 characters. So this is from 0 to 15. So these are the 16 columns, and this is a 5 by 7 matrix. So each character will display it in 5 by 7 pixel matrix. This LCD has a 16 pins. So these are the different pins of this LCD: ground, VCC, contrast, register select, that is RS, read write pin, enable pin, D0 to D7. These are the data pins. Backlight plus, backlight minus, or this is also called as a LED plus and LED minus pins. So let's see this pin in details. So here, pin number 1 is the VSS, that is ground pin. Pin number 2 is a VCC pin that must be connected to plus 5 volt. VEE is the contrast control pin. So in order to control the contrast, we have to connect this pin to the resistor or the potentiometer. So we can adjust the contrast according to the value. Pin number 4 is the register select pin. If we want to select the command register, then we have to make this pin equal to 0, and to select data register we have to write 1 to this pin. Pin number 5 is a read write pin. If we want to write data to the LCD, then we have to make this pin equal to 0, and if we want to read data from the LCD, then we have to make this pin equal to 1. Pin number 6 is a enable pin. In order to enable the LCD or in order to activate the LCD, we have to send a high to low pulse to the LCD. Pin number 7 to 14, these are data pins, D0 to D7, and whatever data we want to write to the LCD, or whatever command we write to the LCD, we want to write to the LCD, or whatever data we want to read from the LCD, that must be placed on this data pins. Pin number 15 and 16, these are the LED plus and LED minus pins, and these are used for backlight. So LED plus pin must be connected to plus 5 volt, and LED minus pin must be connected to ground. So there are different commands we can give to, or we can send to LCD to adjust it. So here the commands or codes in a hex are given for the particular command. If we write 1H to the LCD, so this command to the LCD, that clear display screen. 2H code will command to LCD return home. 4H is for decrement cursor, that is shift cursor to left. 6H is for increment cursor, that is shift cursor to right. 5H is used to shift display right. 7H is used to shift display left. 8H is used to display off cursor off. AH is used for display of cursor on. CH is used for display on cursor off. EH is used for display on cursor blinking. FH is used for display on cursor blinking. Display of cursor blinking. Then here 10H is used for shift cursor position to left, 14H is used for shift cursor position to right, 18H is used to shift the entire display to the left, 1CH is used for shift the entire display to the right, 80H is used force cursor to beginning to first line. This is the starting address of first character of a first line. C0H is used to force cursor to the beginning of a second line. So this is the address for the first character of a second line. And 38H is used for 2 lines and 7-5 matrix display to choose. So these are the different commands that we can give to the LCD. So here are the cursor addresses for some LCDs. So here first is a 16:2 LCD, that means 2 lines and each line contains 16 characters. So here first line, these are the 2 lines, and first line will contain the 16 characters with the address 80H, 81H up to 8FH. So these are the from 80H to 8FH, these are the 16 characters. And for the second line, the first character address is the C0H up to CFH. So these are the total 16 and 16. These are the first 16 characters of first line, and these are the 16 characters of a second line. Another display is a 20:1 LCD, that means 1 line, and it will contain 20 characters and addresses from 80H to 93H. Again 20:2 means 2 lines and each line will contain 20 characters whose addresses are 80H to 93H for first line and C0H to D3H for second line. Another display is a 20:4, that means 4 lines and each line will contain 20 characters. So whose addresses are given 80H to 93H, second line C0H to D3H, for third line 94H to A7H, and for fourth line D4H to E7H. Next display is a 40:2, that means 2 line display or LCD with a 40 characters in each line. So the addresses for that 40 characters, for first line 80H to A7H, and for second line C0H to E7H. So here for 16:2 LCD, the 16 addresses for the characters for first and second lines they have given over here. So here we can see the LCD read operation, how we can read the data from LCD. So here whatever data we want to read, that will be available on this data lines from D0 to D7. So this is the data line where data is available. So data is available only between this part. So before this is there is no data, and after this there is a no data. So data only available between this. Then to read that data, we have to enable the LCD, and to enable the LCD we have to send the high to low pulse before the data is available on the data line. So here we have applied this enable signal to the LCD before the data is available on the data lines. So the timing or TD is the time that is between the, that is before the we have applied the enable signal and the data, actual data that is available on the D7 line. This is called as a data output delay time. Then to read the data, we have to apply the read signal to the LCD. So we have to apply, or to read data, we have to make this pin equal to 1, and we are making this pin equal to 1 before the enable signal is given to the LCD. So this is the enable, or this is the read timing, and the time delay between the or the instant at which we are applying the read signal and the instant at which we apply the enable signal is the TAS. So this is the setup time prior to enable signal going high for both the register select input and read write input, and this is of a 140 nanoseconds minimum timing is there. And when and the instant at which the enable signal goes low and the instant at which this read signal will go low. So this is the TAH. This is called as the hold time after enable has come down for both the register select and read write signal, and this is a 10 nanoseconds. So this is the smaller timer than this setup timer. Then we want to read the signal or we want to read the data. That is nothing but the actually we are reading the command. So we have to select the command register. So here the register select input is given. So we have to select the command register. So we are making this signal equal to 0. And we have to apply this signal at the instant at which we are applying the read signal. And again here this signal will be removed at the same instant at which we are removing the read signal. So in this way we can read data from the LCD. Now how we can write the data onto the LCD? Again here whatever data we want to write to the LCD, that must be available on the D0 to D7 data lines. So this is the portion or the time between which this data is available on these data lines. So whatever data we want to write to the LCD, we have to enable the LCD first. So prior to the data available on these data lines, we have to enable the LCD by sending a high to low pulse to the LCD. So here we are making this enable signal, or we are making this LCD enable before the data is available on this data line. So the distance or a time when this data is available on the data line and when this enable signal will go down, this is called as a TDSW. So this is the data setup time, and it is a 195 nanoseconds minimum. Then to write data to the LCD, we have to select the write operation, and we are selecting this write operation by sending the low signal to the LCD or read write pin. So here we are enabling the write operation by sending or making this pin equal to 0, and here we have making this pin or apply this signal before to enable the LCD, and the instant at which the difference between these two instant, the instant at which we are applying the read signal and the instant at which we are applying the enable signal, that is called as a TAS. So this is the setup time prior to the enable going high for both the register select input and the read write input, and it is a 140 nanoseconds. Then this is the timing between the instant at which the enable signal will go down and the write signal will go high. So we are actually removing these two signals. So the difference between these two time instance is a TAH. So this is the whole time after enable has come down for both the register select input and the read write input, and it is the 10 nanoseconds. Then we have to select the data register to write the, or we have to select the command register to write the commands to the LCD. So here we are selecting the command register by making this pin equal to 0, and we are applying the signal at the same instant at which we are applying the read signal, and similarly we are removing this signal at the same instant at which we are removing the write signal. And this is the time delay. This is a TH when the enable signal will go low and when the data will end. So this is the TH. This is nothing but the data hold time, and it is of a 10 nanoseconds. So in this way we can write the data to the LCD. And here is the time difference between these two instant is TPWH. So this is the enable pulse width, that is of a 450 nanoseconds. This is the enable pulse at which the LCD is enabled and the operation will be performed. So this is the enable pulse width. Now we can see how this LCD is interfaced with 8051. So this is the 8051 chip and this is the LCD. So here we have connected the data pins of LCD D0 to D7 to the port 1 of a 8051. And now the VSS, that is, we are connected the VSS signal of LCD to the ground and VCC pin of the LCD to the +5 volt. Now we have to connect the VEE, that is power supply to control contrast. So this pin must be connected to the potentiometer so that we can control the contrast by varying the value of this port. This is the register select input of LCD that is connected to P2.0 pin of a 8051. If this pin is 0, we select the command register, and if it is 1, then data register is selected. Read write pin of LCD is connected to P2.1 pin of a 8051. If we want to write data to the LCD, we have to make this pin equal to 0, and if we want to read the data from LCD, we have to make this pin equal to 1. Enable pin of LCD is connected to P2.2 pin of a 8051. So here is the program to interface the LCD with 8051 microcontroller. So here we have defined the pin P2.0 as a RS, P2.1 as a read write pin, P2.2 as a enable pin, and here is the main program. So first instruction is move A, #38H. So actually 38H is the command hex value that is used to select the 2 lines and 5/7 matrix LCD. So here we are moving the value 38H to the accumulator, and here the instruction A call COM SB. This is nothing but the command subroutine. We are calling the command subroutine, that means this is the command and we have to write this command to the LCD to select 2 lines 5/7 matrix LCD. Now after calling the command subroutine, we have to give some time to write that command to the LCD. So we have calling here delay. Then again the next command is move A, #E0 0EH. This is used to display and cursor on. By using this command, we make the display on and cursor on. And again, to write this command, we are calling the command subroutine. And to write that command, again here we are calling some delay. Move A, #01H. So this command is used to clear the screen. If if some data is given to the LCD or we have write some data to the LCD, so that data must be clear. So that to clear that screen, we have giving the command 01H. Again, using instruction A call COM SB, we are calling the command subroutine and we are calling the delay. 06H, this value or this code is used to shift cursor right. And again, by using this COM SB, we are calling the command subroutine and give some delay. Move A, #85H is used to cursor at one line position 5. That means we are actually selecting the address where we have to display the character, first character. So 85, our first line's starting address is, first character's address is 80H, and we have written over here the 85H. That means we have chosen the 5th position of the first line. So the first character will display on the 5th position of the first line. And again, to write this command, we have called here the command subroutine and give some time. Now display message. So here, what message we want to display? So if we want to display a name, that is science. So here that character, whatever character we have to display, we have load that character to the accumulator, and here we are calling the display subroutine using instruction A called DISP. So here display subroutine will be called, and to display that character we have give some time to the LCD. Again the second character, that is C, that we want to display on LCD, that will be loaded into accumulator. Again display subroutine will call and some time is given. The next character, that is I, that will be loaded into accumulator, and again display subroutine will be called, and to display that character some time is given. Then similarly here the next character E is loaded into A, and it will be displayed on the LCD using the subroutine display. Then the next character N is loaded into accumulator, and that will be displayed using the display subroutine. So in this way the characters C and E, they will be displayed on the LCD using this display subroutine. Now if we want to repeat this, we have to, or we can add the program here. If we want to repeat it, we can go to this first line here, or we can go to this line A comma #s, or we can simply stop over here, and we have given the command sjump here. Now let's see what are this command subroutine and display subroutine. So here the command subroutine is given. So when this instruction or this subroutine will call, it will jump to this location, that is command or COMSB, that is command subroutine location, where whatever value we have loaded into accumulator, that will be given to the port 1, and port 1 is connected to the data pins of the LCD, so that will be given to the LCD. So to write that command to the LCD, we have to select the command register. So here we are making this RS register equal to 0. That means we are selecting the command register. Then we have to write that command to the LCD, so that we have to choose the write operation. So we are making this read write pin equal to 0 by using instruction clear RW. Then to write that command to the LCD, we have to enable the LCD. So we have to give high to low pulse to the LCD. So we have making the enable pin equal to 1 using instruction set B E, and making it equal to 0 by using instruction clear E. So this is the high to low pulse we have sending to the LCD. And RED, this is the return instruction. So after that execution of this instruction, we will return into the main program, where the next command will be returned to the LCD. Then for display data to the LCD, so this is the display subroutine. So when we call the display subroutine, it will jump over here, where whatever character that is loaded into accumulator, that will be given to the port 1. So that is connected to the data pins of the LCD. Then to display that data, we have to select the data register. So here we are making this bit equal to 1, or this pin equal to 1 by instruction set bit RS. Again we have to write that data to the LCD. So we have to again select the write instruction or a write operation. So we are choosing this write operation by making this pin equal to 0 using instruction clear read write pin. Then again to write that or to display that data onto the LCD, we have to enable the LCD by sending the high to low pulse to the LCD. So we are sending high to low pulse to this enable pin by using instruction set BE and clear E. And after execution of this instruction RET, it will be written to the main program, where the next character that will be displayed on the LCD. So in this way we can display any number or any characters or any graphics on the LCD. So here delay subroutine is given. So for this delay, we have loading the value 4fh into register R1 using instruction move R1 comma hash 4fh. Then here again we have loaded the value 255 into R4 register, and here we have decremented R4 register, and if this register after decrementation, if it is not 0, they have to stay over here. So we have to wait until this R4 becomes 0. When R4 becomes 0, we have to decrement register R1. So here if R1 is decremented and it is not 0, then we have to jump to this location, that is back 1. So here again this R4 register will be loaded with the 255. Again it will be decremented till it is 0, and then again this R1 register is decremented. That means this subroutine will be executed by 4fh into 255 times RET. So after execution of this instruction, it will be written into the main program. So in this way, we can write the data to the LCD. Now here is the C program to interface the LCD with a microcontroller. So this is the first instruction, that we have to include the reg5n header file. So here we have display, or we have defined the port 1 as a LCD data using data type SB. Then we have defined the 0th pin of a port 2 as a RS. Then P2.1 port pin as an enable pin, and P2.2 pin as a read write pin. So here is the main program. So here initialize the LCD. So here we have written the value 0x80, and we have called here delay. So when we have write the value 0x80, so it will call the initialize LCD. That means this is nothing but the command where we have chosen the position of a first character of a first line. So it will call the initialize LCD function. So here in initializing LCD position, this is nothing but the to write command to the LCD. So here whatever num, so whatever value that is assigned to this inside char num, that is nothing but the ATH over here, that will be loaded to the LCD data, and LCD data is nothing but the port 1. So 0x80h is the address of a port 1, so that will given to the port 1. So here to write that command, we have selected the command register using RS register equal to 0. Then we have to write this command to the LCD, so that we have chosen the write operation using command RW equal to 0. And here we have to enable LCD by sending a high to low pulse to the LCD. So in this way, whatever command we have given, that will be written to the LCD using this initialize LCD function. Now write LCD. So here to whatever data we want to display, or whatever characters we want to display on LCD, we have to write over here. So again we have displaying the science word to the on LCD. So here first character that will be given to this write LCD function, and then we have called the delay. So here in a write LCD, this unsigned char num is we have defined it, and whatever character that is given here, that will be loaded to this num. So the value of this num, that will be given to the LCD data, that is nothing but the port 1. And to select or to write this data to the LCD, we have to select the data register. So here by using instruction RS equal to 1, we have selected the data register. We have to write this data to the LCD. That's why again we have to choose the write operation. So here we are choosing the write operation by using command RW equal to 0. Again we have enabling the LCD by sending a high to low pulse to the enable pin of the LCD. And after that it will be written to the main program. So here the next character that will be given to the LCD, and again this function will be called, and that character will be displayed onto the LCD. Again So in this way, the science, these are the characters, they will be displayed on the LCD, and these are the questions for assignment. Solve the questions, and if you have any query, you can ask. Thank you.